Hello friends, welcome to OpenGeology. We are here discussing about the CIL previous year questions. This is part 7 and we will see from question 60 to 70. This belongs to paper that came in 2017. But before we begin, you can join our CIL Geologist test series by downloading our app. There are 100 plus tests are there. Belongs to each section: general awareness, English, aptitude, reasoning and all, as well as geology as well. For other exams as well, you can join our test series. Now let's say the question is soil horizon is the zone of accumulation. So there are different soil horizon zones like where the organic layer is present, A, which is topsoil, minerals and humus are there, E layer, elevated layer, B subsoil, C parent rock and the bedrock. Now the correct thing is subsoil, which have the deposited minerals and the metal salts. So option number C, which shows the B horizon. Okay, so this is a typical soil profile. You should learn about this. Another question is, if you took a gravimeter 1 kilometer down a mine in a rock density of 2.3 milligram per cubic meter, okay, then what would the gravity changed by? So the change is B, that is 212 milligal. Now what is the point here? The point here is calculations, free air effect and the Booger's lab collections. So this is the formula. You just put the value of density and the value of h, that is the distance 1 kilometer. Okay, I think there is centimeter, cubic centimeter. I just forgot it. I will mention this in the description box if there is any change. Now another question is the process of diagenesis. So you know what is the diagenesis? It is change from sediment to the sedimentary rock. Okay, sediment to the sedimentary rock. So that is why it has the temperature and pressure which is lower. If it is further increases, it will be converted into the metamorphism. So for diagenesis, it happens in the shallow depths in the earth's upper crust only, and the temperature range is 200 degrees Celsius. So if it is going more than 200, we call it a start of metamorphism. Okay, so it involves early stage alterations like the compactions and the cementation processes. Another question is depth of ocean floor shows remarkable relationship. So the depth of ocean floor is generally related to the age of crust. Like the primary control mechanism behind this is as the seafloor depth versus the age depends on the older rock. As you know, the ocean starts from the mid-oceanic ridges. As it goes away from the mid-oceanic ridges, it gets older, and as it gets older and away from the heat, it starts to contract. It starts to contract, then becomes a little bit high in the density, and it starts to sinking. And that sinking yields a predictable relationship between the depth and the ages. So correct option will be our D option. Now another question is a magnetic gradiometer would probably be superior than a magnetometer. Now this is the statement. Now why it is superior? So it is because of it can locate a faulted margins of a lava beneath a meteor or the two of the soil. Beneath a meter means the accuracy, you can say, beneath a meter. So what is a magnetic radiometer? It measures the rate of change of the magnetic field rather than the total magnetic field. So generally magnetometer, what happens is simply measures in the magnetic field, how much magnetic field it is there in terms of, you can say, Tesla or nano Tesla. But a magnetic radiometer measures the change in the magnetic field. So change is more sensitive to shallow and near surface magnetic sources. It is better at detecting the sharp boundaries and edges of the magnetic bodies, and it is also less affected by the broad regional magnetic variations. So all of these three makes it important for the faulted margins, okay, for the measurement. Another question is, which of the following represents a typical contact zone metamorphic reactions? So there are you can say good metamorphic reactions or representative metamorphic reactions for each of the metamorphic zones. Like you have the geolite phases. Okay, so there are reactions which are found only in the geolite phases. So you have the green zest phases. You have the green zest phases because of the green minerals. So they are characteristic of green zest phases. You have the amphibolite phases. Okay, like you have the last one is the granulite phases. So pyroxene comes in the granulite. So it is a characteristic part. Like you have the presence of sterolite. So you have the sterolite zone. You have the kyanite zone. So they are because of their specific reactions. Now for the contact zone metamorphic reactions, the chlorite, muscovite, especially the cordierite. Okay, so cordierite is diagnostic of low pressure and high temperature mineral. That is why whenever we have the cordierite, we generally believe it must be a contact zone metamorphic reactions. Okay, so especially forming the Hornfels species from a paletic protolith, there must be a cordierite. Another question is, dislocations are defined in terms of, they are defined in terms of the Burgers vectors. Now how are they defined? Like you have a mineral like this, there is one dislocation here. Now this dislocation is migrating from here to here. How it will migrate? It will migrate like this. Okay, then it will shift to the third one, then again it will shift to the another one. So the Burgers vectors represent the magnitude and the direction of atomic displacement, which direction it is displacing, that occur along a dislocation moves. Okay, next question is, which of the following isotopes are Primeval, means the oldest one? So the potassium argon, it is with a half-life of 1.25 billion years, still present naturally. Then the uranium 235 with a half-life of 704 million years, it is also considered as the Primeval. Then you have the strontium, a stable isotope which is already present in the Earth's formation. So these three are considered as the Primeval or the primitive radiometric isotopes. So option number 1, first, third and the sixth is the correct answer. Okay, next is the value of G at place varies with the time due to. So the value of gravity changes with the time due to the topography of the continents. Now why? Because of the elastic rebound theory. You know, elastic rebound theory merged with the isostasy. Okay, we call it the isostatic rebound. Okay, so as the continuous distribution of mass under the Earth's crust, it changes the local gravity field, which changes with the time. This vertical movement of the continental crust, like the isostatic movement, adjustment, they are adjusting to a level of depth of compensation. So this adjustment re-establishes the isostatic equilibrium, which always changes the value of gravity. This is how the value. What you can also learn the different types of isostasy, like the Airy's theory, Pratt's theory. So all of these things you should learn. Okay, last question of this video is, which of the following data gives the maximum vertical accuracy? So it is given by the LiDAR. LiDAR is the it depends on the light. So specifically designed for the topography and 3D mapping. What it uses? It uses a short wavelength laser light to measure the distance with incredibly high precision. How much precision? Accuracy can be ranges from a few centimeters to even the millimeter distance. Okay, so LiDAR is one of the most important for the vertical accuracy. It's all about for today. You can join our CIL test series. There are 100 plus tests belong to all sections, like the general awareness, English, reasoning, aptitude, as well as the geology, and we have the 11 full length test. Okay, so thank you so much. We'll see you in the next part.